Let's solve the following linear equation. It's 1/2 x plus 8 equals 1/6 minus 1/4 x. Now it's everyone's favorite. The fraction appears in this linear equation, and though we could just treat these fractions as any other coefficients and numbers and just solve the equation the way we solved the previous linear equations, maybe the best thing to do in this case is to actually clear the fractions. So in order to do this, we need to find the least common multiple, LCM, of 2, 6, and 4. And basically what we're looking for is the number that is basically a multiple of both 2, 6, and 4, and the smallest of such numbers, and that number actually turns out to be 12. So what I'll do is I'm going to multiply through by So I'm going to multiply through by 12 the linear equation. So in order to not make a mistake, I'm going to use plenty of parentheses. So I'm going to do 12 times the left side of the equation. So it's 12 times 1/2 x plus 8. And we also want to do 12 times the right side of the equation, which is 1/6 minus 1/4 x. Okay, so let's see, on the next page I'm going to just recopy what we had. So it's 12 times 1/6, oops, excuse me, so undo, 1/2 x plus 8 is equal to 12 times 1/6 minus 1/4 x. Okay, so now I'm going to distribute, and when I'm going to be dealing with the fractions, I'm going to rewrite 12 as 12 over 1. So as I distribute the 12 through this sum, as I do 12 times the first term, I'm going to write 12 as 12 over 1 just to make things easier to see. So it's 12 over 1 times 1/2 x plus, I still have 12 times 8, and then here again I'm going to write 12 as 12 over 1, because as I distribute the 12 through this difference, I'm going to be dealing with fractions. So this becomes 12 times the first term, which is 1/6, minus 12 times, so it's 12 over 1 times 1/4 x. Okay, and now the reason I wrote 12 as a fraction, so I wrote it over 1, is so that I can cancel easily and get rid of these denominators. That's why we chose the 12. As I cancel the 2 and the 12, I have a 1 left here, and I'm going to have a 6 over here. So I end up with a 6 over 1x, which I'm going to just write down as a 6x, plus 12 times 8 is 8 times 2 is 16, 8 times 1 plus 1 is 96, equals the 12 and the 6, we have a 1, 2, so the 6 goes into 12 2 times, and the 4 here goes into 12 3 times. So we end up with a 2 over 1, so I'm just going to write a 2, minus a 3 over 1 times x, so I'm going to write a 3x. Okay, so, well, that's great. Now I'm going to add 3x to both sides to finally finish solving this equation. So we end up with 9x plus 96 equals 2. And as I go on to the next page, I have what the plus 96 equals 2. I'm subtracting 96 from both sides of the equation, and I end up with 9x is equal to 2 minus 96 is negative 94. And so now to solve for x, I'm going to divide through by 9 both sides of the equation. Now I'm relenting, and this becomes x equals negative, so the negative sign in the numerator can be brought out in front of the fraction, and this becomes negative 94 over 9. And I'm going to leave the answer like this. I don't see a point in actually doing the division. Minus 94 over 9 seems like a perfectly reasonable way of presenting the answer. And by the way, I know that I cannot cancel anything because, let's see, well, how did I figure this out? 94 is not divisible by 3, and you can look up later divisibility rules and look it up, especially if you feel lost without a calculator. What we want to do is for you to be able to stand on your own feet without feeling like you're lost doing mathematics without any kind of calculator. So this is all about independence and freedom. So check out the divisibility rules that are to come later on, because using those I could tell that neither 3 and therefore 9 do not divide into 94. Okay, well, that's it for now. So that is the solution, and talk to you guys later.